So this is problem 1.5, and it asks, how do you make 0.5 liters of pH 7 when you have 0.1 molarity of phosphate buffer, and it gives you the pKa with NaH2PO4, it gives you the molecular weight, and Na2HPO4, and it also gives you the molecular weight. So we're going to be using this equation for this problem. And so the first step is to plug in what we have into this equation. So we know we have 7 for our pH. Our pKa is 7.21 plus log, and then this is going to be conjugate base over acid. So we're going to subtract our pKa from our pH, which is gonna give us negative 0.21, which is going to equal log conjugate base over acid. So next we're going to pretty much do the inverse of log. So we're going to put this number here for the 10, which is going to equal conjugate base over acid, which is going to equal about 0.617. And so then we're going to kind of flip this around a little bit so we can get this number. So we're going to get our conjugate base. So when we flip this around a little bit, so we're pretty much going to multiply conjugate acid. It's going to cancel it out and multiply it here. So we're going to get HA, which is going to equal our conjugate base. So since we know what our conjugate base equals, we can plug this into conjugate base plus conjugate acid equals 0.1 molar value of the phosphate buffer, which is these two combined. And so we're going to plug this in for here. So it's going to be 0.617 HA plus HA, which that value is just going to be 1. So we're going to add these together and we're going to get 1.617 equal to 1 molar. So let me write that out. So now we're going to solve for HA. So divide each by 1.67. These are going to cancel out 1.617. And so our HA is going to equal 0.062 molar. And to get our conjugate base, we're just going to subtract 0.1 molar from this number, and that's going to give us 0.038 molar. And so now that we have both of these numbers, we can solve for the grams that will make up the phosphate buffer in 0.5 liters of water. So first we've got to determine which one is our conjugate acid, and that is going to be the one with the most hydrogen. So this is our conjugate acid, so this is going to be our value for that molecular weight. So this is also going to be our conjugate base. So we can go ahead and solve for this conjugate acid. So it's going to be VHA equals 0.5 liters times 0.062 moles over liters, and that's going to cancel out, and that's just going to give us regular moles. So when you multiply those together, you're going to get 0.031 mole. And I'm going to skip all the in-between stuff about 1 mole over, grams over mole, and then moles over moles, and because all of it's going to be equal anyways. So I'm going to go ahead and multiply this by 11998 grams, which is going to give us 3.71 grams of NaH2PO4, which is equal to our conjugate acid. So now it's time to solve for the conjugate base. So we're pretty much going to do what we did up here with different values. So 0.5 liters times 0.038 moles over liters, which is going to give us 0.019 mole. Again, skipping all the in-between stuff because everything is a ratio of 1:1, so we don't need to do that. So then it's going to be times 141.9 0.96 grams, which is going to equal 2.70. Now we're given the answer for this equation already, so the answer was 2.71 grams, and since this is very close, that can be equated to just rounding. So as long as it's within like a value or two. So this is Na2H2PO4, and these are both of our quantities, so we're getting, well, we're going to call it 2.71 grams and 3.71 grams of both of these chemicals in 0.5 liters of H2O, and that's going to make up our phosphate buffer.